Next question is, how does operator overloading work in Python? And let's give some examples. So operator overloading. And then we'll talk about how it can work with len, square brackets, and plus. Okay, so first of all, the idea of operator overloading is that the same operators that you use with built-in types can work on your types as well. So we know I can say 2 plus 2, 2 plus 3, let's make it really exciting. 2 plus 3, and that's 5. Hope you're not surprised by that. A, B, C, D plus E, F, G, H. So notice that I can add together 2 ints, 2 strings, or even 2 lists. And now I have a new object based on those. And that's because the plus operator knows how to work with ints and with strings and with lists. Now, how does this work? It's not because the plus operator is super smart. It's because the plus operator is actually turned into a method call. And so the general rule for operator overloading in Python is find out what method is being invoked by the operator, and then you write that method. And that method then is invoked on your objects as well. So if you want to use operator overloading on your objects, you just need to implement the right methods. So for example, if I say here, class, let's say person. I'm going to say here def init self name. Self name equals name. Okay, so far so good. And now I say p equals a person, and we'll say the name is Reuven. What coincidence? And now I say len of p. What is the length of p, this instance of person? And the answer we get back is, hey, there is no len. All right, we'll see in just a few seconds here. Something's kind of stuck on the computer today, eh? There we go. Object of type person has no len. So what's going on? Len, the built-in function, looks for a certain method. It looks for a method called dunderlen. So if I define here def dunderlen self, must take self, but doesn't take any other arguments, I can return any value I want so long as it's an integer. So I can just say return 3. And then when I say what's the len of p, it's just going to say 3 for everyone. But usually you're not going to want to do that. You're going to want to actually calculate something. So I can say you return the len of self.name. Maybe not the most intelligent way to do it, but it actually works. So what you see is len, the function, is looking for dunderlen, the method. And that's so typical for all these operators in Python. Now, what happened before? When I would say len of p, before I implemented my dunderlen method, it would look on the class, didn't find dunderlen. It would look on object, which is the object from which everyone inherits, and didn't find it there, and then it would give us this error. Okay, so let's try this again. What if I say now p of 3? So p square brackets 3 is also going to give us an error here. And it says person object is not subscriptable. Well, it turns out that square brackets in Python also invoke a method. They invoke a method, though, that takes 2 arguments. Def, it's going to be get item, self, and then we can say index. That second argument, index, is what from whatever was in the square brackets. So I can say return, let's do self.name, square brackets index. And now what's going to happen? Well, len of p is still going to work because it's not affected by this. And p subscript 3 is going to return v. R-E-U-V, 0, 1, 2, 3. That's the element that was returned. And so what's happening here is we are invoking p underscore 3. And that means that's really invoking p get item 3. And indeed, every time you use square brackets in Python, this is what's happening. This is why strings, lists, tuples, dictionaries all use square brackets, even though only lists are defined with square brackets. It's because square brackets are always turned into this method call. If you implement this method, then this method call will work just fine. So, by the way, if I say p of 2 until 5, what are we going to get? Look at that. The slice works as well. Now here it happens to work because I passed a slice to a string, and strings know what to do with slices also. But slices are just passed along the same way as an integer is. And of course, if you want to, you can also take things that are not integers and not slices. You can take strings, you can take tuples. It's up to you what you want to do with that argument. It's completely up to you. Well, what if I now want to add together 2 people, right? And we're going to, okay, so what if I do this? What if I say now, I'm going to implement this, and now I'm going to say P1 let's just call it name1. And then we'll say p2 equals person name2. And so now we have two people, and if I say p1 plus p2, what's going to happen? Well, actually, we're going to get an error. It's going to say, I don't know what to do here. So what happens when we add two objects together? It invokes the dunder add method, self and other. And this self and other business is used in many, many different operator overloading magic methods. We have, of course, the ones for the regular mathematical ones, add, sub, mul, div, pow, and mod, sure, but also for dunder EQ, if they're equal to each other, or any not equal to each other, and so on and so forth. So there's going to be self, meaning the current object, meaning the object on the left, and then other, which is the object on the right. So when we say p1 plus p2, what we're really saying is I want to do p1 add p2. There's no difference between these two forms, except that the first one, the one on the left, is much more convenient to write. So I can say here, return self dot name plus other dot name. But wait a second, that's just going to return a string. Is that really what I want to return? Typically, I want to return, it works. Python's not going to complain. But if I add two integers, I get an integer. If I add two lists, I get a list. If I add two tuples, I get a tuple. So if I add two people, I should get a new person. So really what we should be doing is saying return person of self-name plus other name. A little weird perhaps, but yeah, that'll actually work. And now we have a new person object that we can use. So this is how, in a nutshell, simple operator overriding works. I'll show you one more thing though, which is what happens if I now say P1, or I'll show you two more things, P1 plus ABC. We're going to get an error. We're going to get an error saying that there's no attribute name, meaning what happened? P1 plus ABC. So indeed, we ended up saying P1 add of ABC, and this method was called, and then it looked for self.name and other.name, but other is ABC, the string, and there is no name attribute, and that's exactly the error that we got. So it's pretty common then to say, well, wait a second, I'm going to check to make sure it has that attribute. I'm going to say if has adder, other, and name, then I'll do this. And then you can decide what you want to do in other cases. You can say else, return person of self.name plus stir of other. That's one option. Maybe not the best option, but an option. So now P1 plus P2 works just fine. And P1 plus ABC also works fine. Here we go. We got a person object out of that. But what if I say ABC, oops, what if I say here, ABC, not searching. There we go. ABC plus P1. Well, now it's sort of weird, right? Because now we're basically saying ABC add of P1. And clearly our string object has no idea what to do with its user-defined class P1, right? That just wouldn't make any sense. And indeed, we're going to get an error from this. But it turns out, right, can only concatenate stir to stir. But it turns out that Python's a little smarter than that. Python actually gives us a second chance. If the string doesn't know how to add itself to a person, it says, you know what if we try in the other direction? And it then looks for, on your object, radd, reverse add, or right side add, self and other. And now we can do exactly the same thing as before, except that it's going to be turned around in the other direction. And watch what will happen now. If I had a, okay, and then we'll do self, we'll do other name, plus self name. Otherwise, we're going to say stir of other plus self name. And now if we run it, it works here. And now if we run it, it works here. This is then going to run the regular old add. And this now is going to, turns out, work as well. Now you'll also see that all these objects are really like displaying a really boring printed representation of themselves. So I'm just going to say here def dunder repr. Guess what? It's another magic method we can use to override. And this one is not just adding functionality. This is taking the place of functionality that's in object. Object, the ultimate object in the object hierarchy in Python. It's the one that has repr and stir looking like this. So I'm just going to say here, return, and we'll say here it's a person with vars of self. And vars gives you the attributes of that object. And so here we're going to have, it's a person with name of name1, name2. Here it's going to be person with name1, ABC. And here it's going to be person with ABC, name1. So there are lots and lots of these magic methods, as they're known, that you can use for overriding operators in Python. But as you can see, each operator has its own method And over time, you'll get to know more and more of them. But this is true for all operators, including some of the weird ones. Like, why is it that in NumPy you use the tilde and the ampersand and the pipe to do not, or, and and? Well, not and or, depending on which order I said it before. Why? Because those are operators. They're used for bitwise calculations in Python. But guess what? You're not going to do bitwise calculations with NumPy arrays. But what you can do is override those operators so they can be used for other things. And that's exactly what they did in the NumPy world. So operator overloading, definitely available in Python, definitely an easy, good thing to do, and definitely something that you should know how to do for your interviews.